Imagine that you are going to buy something in an extremely large department store. If it is the first time going to the department store, you didn't know the plan for previously, you may end up getting lost and cannot find the commodity you wanted to buy. On the other hand, if you already have the planned route for the shopping mall, how many time you are going to save? Moreover, what if you can get a discount message for your shopping item? Some technical method of the positioning system and the software could solve the above problems. This technology is not only can provide a better shopping experience for customers, but also benefit for the companies. The companies can have the customers' information immediately and make the operation more efficient, like to plan the route for customers so the customer can have more time and energy to buy other goods. Therefore, they can reduce the storage capacity and save the cost. So seems like this kind of a system can be really useful, and maybe it will change the shopping manner in the future. But how can we achieve that? For now, there is a system called Indoor Positioning System (IPS). Use the magnetic sensor to scan the indoor structure, and with the magnetic scan, the process can be very fast. Because the geomagnetic is everywhere and the spatial distribution are different for every single place, just like a footprint. And the information can be collected quickly and easily, so that we can use other technique to position your location. So, is there any applications for the IPS system? Of course. For example, in the building, it can be used for your safe problems. Combine the virtual reality or other techniques for the game. Make it easier for your interior design. Or it can be helpful for an engineer when solving the engineering problems. After the introduction of positioning system, let's talk about the sensor category of the positioning system. It can be divided into different categories. For example, magnetic field detection, Bluetooth signal detection, and the visual information. Let's introduce the magnetic field detection first. Owing to different sensing mechanisms, magnetic sensor can detect the magnitude or directions of the external magnetic field. Today we will introduce the vector magnetometer. Here's the summary tables of today's introductions of magnetometer. Fluxgate, artifact, main-space, and magnetoresistive magnetometers. Let's get into the parts of fluxgate. Fluxgate is composed of a pair of coils. One is the driving coil while the other is the sensing coil. When the driving coil is supplied with the AC signal, according to Faraday's law, the sensing coil will experience an induced voltage. When the external field is applied on the fluxgate, the different regions of the fluxgate will endure different directions of magnetic field. Consequently, the induced voltage will be changed. The rule of thumb of designing fluxgate are as follows: suitable operation frequency, number of turns of sensing coil, cross-section, and magnetic properties of magnetic core. Most of these achieve lower power consumption by operating the sensor on a minor hysteresis loop. Let's talk about Hall effect-based magnetometer. Hall sensor is composed of an electrical conducting pad with the different input and output terminals. When the external field is applied on the device, the electron inside the conducting pad will endure the Lorentz force, and there will be a voltage difference at the terminal orthogonal to the input current directions. When the external field is larger, the Hall voltage will also increase. The Hall sensor is the most widely used magnetometer. Moreover, the electrons in the semiconductor must have a higher drift velocity than those in the metal. Let's move on to the next category, main-space magnetometer. Main-space magnetometer is using the MCK operation system, which composed of the movable proof mass, sensing part, and the spring. When the external field is applied on the device, conduction path embedded in the proof mass will endure the Lorentz force, since the movable spring mass system will move, and the sensing part of the device will have the signal change due to the different sensing mechanisms. Usually, the main-space magnetometer is also named the resonant-type magnetometer, so the device is operated at its natural frequency. The resonant magnetometer is compatible with the general semiconductor fabrication process. The sensing mechanisms can have many options. The Lorentz force induced by the magnetic field could deform the suspended main structures with the small stiffness. Let's get into the parts of introductions of GMR-based magnetometers, AMR, GMR, and MTJ respectively. What is the magnetoresistance? Magnetoresistant magnetometers use the change in the resistance caused by an external magnetic field. Value for the magnetic resistance are given as where is the value of the resistance. Here's just introduced the three types, AMR, GMR, and MTJ. AMR, anisotropic magnetic resistance. Some materials, such as the permealloy, exhibit an isotropic magnetoresistance. In such materials, the resistance depends on the angle between the magnetization and the direction of the current flow. The original magnetization of the material's angle will change corresponding to different external magnetic field, which further change the resistance of the device. The feature and the importance factors of using the mechanisms are as follows. Anisotropy of the materials is easily influenced by the environmental temperature, so the device will need temperature compensation. GMR, the effect was named giant magnetoresistance or GMR. In its simplest form, GMR is achieved by using the four-layer structure that consists of the two thin ferromagnets separated by the conductor. The fourth layer is an anti-ferromagnet that is used to pin the magnetization of one of the ferromagnet layer. The ferromagnet layer that is being pinned is between the conductor and the anti-ferromagnet. The pinned ferromagnet is called the hard ferromagnet, while the unpinned ferromagnet is called the soft ferromagnet. When the external field is applied, the magnetization of the free layer will be changed, then the resistance of the device is changed. Different direction of the external field would have different induced direction of the magnetization. Since the information could be extracted, GMR effect is used in most of the computer's red hat, where it shows more 1/over frequency noise than the AMR. MTJ, magnetic tunnel junction. It has the structure similar to the fourth-layer structure described above in GMR sensors, but in this case the intervening layer is an insulator. In MTJ sensors, the conduction occurs by tunneling of the electrons across the insulator. The insulating layer must be very thin, about 1 nanometer thick, and usually will use aluminum oxide. When the external field is applied on the sensor, the magnetization of the free layer will be changed, then the resistance of the device is changed. The main difference with the GMR is that the MTJ is using the tunneling current between them. MTJ will also have less power than GMR, low cost, energy efficient, and high sensitivity, but the inherent noise larger than the Johnson noise limit. After introducing magnetic field detection, we can move on to the next category. In this part, we are going to introduce Bluetooth low energy signal detection. So what is BLE signal detection? It is just like a lighthouse near the coast, keeps shining the light, and the ship can follow the light to get the right directions at night. You can think of Bluetooth low energy beacons as a similar idea. Beacons keep sending the radio frequency signal to the nearby region, and we can use the Bluetooth device to detect the signal. So for indoor positioning system application, how can we make it work? First, you have to install the beacons to several places. The number of beacons you need depends on the area of the floor. We just need to use specific software to calculate the signal strength. After analyzing several data points, we know where we are, and this is how Bluetooth signal detection works. Then we are going to introduce the positioning system based on the visual markers. The idea is to take snapshot by camera-enabled mobile device and decode the location coordinates from visual markers. In these systems, markers are placed at specific locations throughout the venue, each marker encoding their location coordinates, latitude, longitude, and height of the floor. Measuring the visual angle from the device to the marker enables the device to estimate its own location or coordinates in reference to the marker. A collection of successive snapshots from a mobile camera of the device can build a database of image, which is suitable for estimation of the location in the venue. Once the database is built, a mobile device moving through the venue can take snapshots, which can be interpolated into the venue's database, yielding the location coordinates. We can give a comparison between these techniques. For Bluetooth signal, we have to install the beacons and consider the power consumption. sending signal more frequently, giving the higher position accuracy, but consume the battery fast. It takes more time for the maintenance. Sending signals less frequently, consuming less power per signal. Visual precision system gives a precise estimation, but it requires a special sensor like Google Lens. For magnetic field IPS, we can use the built-in magnetic sensor we mentioned in the previous part to measure the geomagnetic field for indoor positioning without any extra equipment or special sensor. Actually, the IPS system is one of the applications of IoT. So what is IoT? It is the concept of everyday objects, from industrial machines to wearable devices using the built-in sensors to gather data and take action on that data across the network. So it is the building that uses the sensors to automatically adjust every actions of the system, or the production equipment will alert the maintenance personnel to an impending failure. Simply put, the Internet of Things is the future of technology that can make our life become more efficient. For the shopping case, customer can get information from many stores easily, and the stores can collect lots of data from the customer because of the IPS system. And these things happen after we have the IoT concept and the brand new technology. IoT is making our life better, and there's still a lot of applications can be developed. So what is the coming future? We'll see. Thanks for your watching, and please give us a like if you like this video.